Our plenary speaker is an author and co-author of books, book chapters, and articles. He coordinates the Laboratory of Digital Content of the Department of Education and Psychology. He is the director of the doctoral program in Multimedia in Education. With main activity in postgraduate studies, he supervises several postgraduate students, all of them PhD and postdoc students. His main research interests are cognitive flexibility hypertexts, learning communities and communities of practice, random access instruction, and cactors. He was, for 5 years, director of the Department of Education and Psychology and is vice coordinator of the Research Center in Didactics and Technology in Training of Trainers, at the University of Aveiro, Portugal. The title of his presentation is, Can Data Analysis Using a Software Provide Rigor? Let's welcome our plenary speaker, Antonio Moreira, PhD.
Dr. Antonio, we welcome you. We're glad that you can join us. We look forward to hearing from you. And at this point, I'd like to hand over the floor to you. Thank you very much.
Can you hear me?
Yes, I can hear you.
Okay. Well, thank you so much. So I'm going to deal with this. Well, good morning again. I was asked to start my video, but the problem is that I think it will be difficult to have a proper connection if I keep the video running. But anyway, I will do it. I'll just leave the video running. Well, can data analysis using software provide rigor? This is a question for which I do not have the answers, but I have some ideas that I would like to share with you as to what can be done to get close enough to this question's response being positive. I will move on to computer-assisted qualitative data analysis software. What it does, it allows an analysis of huge amounts of data. But although the priority of qualitative data analysis is not to analyze large amounts of data, the ease with which data can be organized and imported often means that users will be more prone to adopting an open attitude towards it. Validation procedures, whether internal and external, are also included. For instance, the Delphi technique, based on the principle that the predictions of a structured group of experts are more accurate when compared to those coming from unstructured or individual groups. Each element is thus isolated from the influence of the others, but on the principle that they are experts. Kleinnijenhuis alpha, a coefficient, a statistical measure of the agreement achieved when coding a set of units of analysis in terms of the values of a variable or an attribute. The Cuilenburg coefficient, also a statistics used to measure inter-rater reliability of qualitative items. It is generally considered to be a more robust measure than the simple percentage calculation of agreement, because Cuilenburg takes into account the possibility of agreement occurring by sheer chance. Later on, we will give examples of internal validation procedures using WebQDA software. Or computer-assisted qualitative data analysis software also allow inductively and deductively defining categories coding and recoding, exploring and crossing different data formats, for instance, text, image, audio, and video. After the first reading of the data and respective coding, depending on the method that defines the application of a particular data analysis technique in the coding procedures, it is necessary to reread the coded data. The potential of using software is that the user can quickly access the contextualization of the coded unit of analysis. Well, a unit of analysis can be just a word, a phrase, a sentence, or a paragraph. Thus, the researcher can read what was said before and after the coded text, and depending on that, record part of or all of the unit of analysis, or add before or after parts of the text that not coded or decoded. The work of coding is quite time-consuming and laborious. However, without the use of software, it is much worse. Characters also allow for advanced visualization of data. Concept maps, dendrograms, code maps, density maps, among others, help researchers to create synthesis of data and results. However, often when inserted into a paper, they lack explanation of what is presented. Currently, there are dozens of online tools just creating dynamic dashboards and infographics. Communicating science through infographics has been widely explored in research in general. Listing the disadvantages in the use of these tools is something that accompanied the emergence of these software packages. Brent in 1984 already mentioned as a disadvantage the computational skills that researchers would have to acquire. These skills are still today one of the main barriers to the use of software. The researcher invests a lot of effort in learning how to use a certain tool. Gibbs, Fraser, and Mangabeira state that software is less useful for addressing issues of validity and reliability in the thematic ideas that emerge during data analysis. We are talking about an article that is almost 20 years old. The first cactus appeared in the 1980s, and in 2002, we believe it currently, from what we have already presented, it is no longer valid. Ryan, in 2009, concluded that software packages allow researchers to make the methodological processes of a study visible and thereby make it more reliable. Davis and Meyer, in 2009, suggested that it is essential that the researcher learns to explore the software before using it in the project, and that the researcher cannot be separated from the software. The researcher decides which features and capabilities to use and when and where to apply them. Computational tools tend to be specific and especially useful when you have qualitative research with a large volume of data, when you need to cross-reference information from the attributes of research participants. On the other hand, there are a number of criticisms that are pointed at the use of software in qualitative data analysis. One of them is possibility of losing control in the coding process, confusing software with methodology, encouragement of complex and detailed coding structures resulting in overcoding, unnecessary increase in the amount of data collected, leading to the risk of compromising in-depth analysis, impossibility of communication between systems, which means software packages not running on various operating systems. lead researchers to use a particular method of analysis according to the characteristics of the tool itself. As mentioned by Evans, Silver, Mark, and Peters, there is no best software. Each program has its advantages and disadvantages, and for this reason, there is no software that is better than all the others in all its functionalities for qualitative analysis. It is therefore understandable that researchers often have difficulty deciding which package to invest in time and learning efforts. It should be referred that the content analysis technique entails tedious tasks and that computers could facilitate some tasks, essentially in the coding phase. Brent stated that the analysis of qualitative data involves a number of tedious and time-consuming tasks that most researchers would like to escape from. Even the most conscientious qualitative researcher quickly begins to think that such tasks are not an economical use of their time. However, such tasks require sustained theoretical foundations and are therefore difficult, if not impossible, to delegate to others. And they are also impossible to delegate to software package. Numerous technological solutions have emerged to support researchers in almost all phases of research projects. In general, the use of these tools allows for more agility and completeness, making it possible to work an extensive volume of data in an organized and quite coherent way. Qualitative research has benefited from enormous progress in terms of methods and techniques with intensive use of technology. The current demands in the research context compel more and more researchers to equip themselves with digital tools that provide speed and efficiency in their research processes. Regardless of the nature of the researcher, when using digital tools, seeks to ensure that the data collected are analyzed in a careful, rigorous, and systematic way, more effectively managing the time spent and increasing the reliability of the results obtained. Different application fields explore tools to support qualitative data analysis, the so-called computer-assisted qualitative data analysis software or qualitative data analysis software, as is the case of the WebQDA software. The simple use of a computer-assisted qualitative data analysis software does not guarantee the rigor that the researcher should advocate. Regardless of the use of software, the researcher must define the research questions and objectives, develop the method, data collection techniques, and data analysis techniques, and then look for the computer-assisted qualitative data analysis software that best suits their research project. Based on its definition, perhaps the term rigor, often used in positivist-based studies, is not the most appropriate term for something that relies on processes and procedures. The visualization of the structure of the software itself allows the more inexperienced researcher to understand that their decisions and conduct will be reflected in the scientific credibility that will be transmitted through, for example, the publication of an article. The integrity of the researcher is a dimension which concerns the rigor of the study. In the case of the WebQDA software, a software that supports qualitative data in a collaborative and distributed environment, although there are some software packages that treat non-numerical and unstructured data like text, images, video, or audio in qualitative analysis, few are those that can be used by several researchers in a collaborative and distributed work environment as the internet can offer. In this configuration, WebQDA allows the user to explore validation techniques not yet optimized for various techniques such as referred before, the Delphi technique, Kleinnijenhuis alpha, and Cohen's kappa. With the possibility that it can be applied to all three techniques described, Creswell and Miller state that when proceeding to a coding work, initially one should not expect to obtain more than 70% agreement. Ideally, both intra and coder agreement should be close to 90%, but such a situation is difficult to achieve. Rigour and colleagues in 1990 state that the search for synchronous validation can become very stimulating for the researcher, as it forces them to reflect on the fact that slightly different results can be simultaneously true. Although this encoding process may be considered reductive, as it leaves part of the richness of the information in the shade, this type of analysis is irreplaceable at the validation level. As Data already argued, as Vala already argued in the 1980s, any content is susceptible to different interpretations, depending on the analysis and depending on the analysts. For instance, two coders analyzing the same material will certainly arrive at different results. This aspect is part of the nature of qualitative research itself. In this framework, when we involved experts to validate the model of categories, we did not corroborate what Gibbs, Friese, and Magambea state that computer-assisted qualitative data analysis are less useful for addressing issues of validity and reliability in the thematic ideas that emerge during data analysis. Another dimension of the rigor of the work conducted online is the integrity of the researcher. They collect, validate, and analyze data online. They transfer and share information, involve different stakeholders at different points in their study. This flexibility and ease of the user's actions often leads them to ignore the defined methodological steps. You can always adjust it in the face of some constraints and limitations that have emerged throughout the study. This implies an ethical pact with you and the others involved. As with the use of another type of tool, such as the word processor, which allows us to present articles and reports using different formats and supports like images, tables, graphs, fonts, organization of information, etc. Computer-assisted qualitative data analysis software has also become increasingly robust. The act of using a computer-assisted qualitative data analysis software that works online or offline does not confer more or less quality to the work carried out by the researcher. However, the rigor and systematization one brings to one's work depends on human behavior. A word processor does not write alone either, although there are already voice recognition and audio transcription functionalities. Even if a computer-assisted qualitative data analysis software is used, the researcher remains one of the instruments of data collection. The care taken in the different phases of validation procedures makes it possible to reduce or minimize the bias often associated with qualitative studies, often seen as a problem, but nevertheless a characteristic of this type of approach. The most relevant aspect of using a computer-assisted qualitative data analysis software that works online is the possibility of working collaboratively, synchronously or asynchronously. Some studies have been conducted on WebQDA, such as collaborative work coding in real time by Costa in 2020, collaborative work in qualitative research through technologies in Costa et al. In 2006, collaborative work supported by technologies, the example of qualitative research by Costa and Costa, and features for the promotion of collaborative work in qualitative research, the case of WebQDA software, Costa et al. Another quite interesting dimension involves analyzing the tools that allow checking or assessing the quality of a scientific work, essentially articles. Tools such as the Qualitative Research Education Tool, QRE tool, by Costa and Minayo in 2019, consolidated criteria for reporting qualitative studies, COREC, Booth et al. 2014, and the enhancing transparency in reporting the synthesis of qualitative research and track by Tong et al. 2012 in their checklists questioned the number of researchers or coders involved. These tools assume that collaborative or cooperative coding procedures in this example involve more than one researcher. WebQDA happened as an idea when in our department at the University of Aveiro, licenses for en vivo became prohibitive. We were lecturing, supervising masters and PhD students. And when it came to analyzing qualitative data, we either used a single license of an outdated version of en vivo running on an outdated version of system software installed on a single outdated PC, or we just decided to do the analysis by hand using pen and paper. The question was, can we come up with a software that is paid by the number of months you need it and that runs regardless of where you are and is not operating system specific? And that is what we did. You do not need to install the software, it runs in the cloud. You can code along with the other researchers on the fly, and your work can be retaken again whenever you want it and for the span of time you need. Along the years, we have been capitalizing on the various usability and user experience studies we conducted and that allow for the improvement of the software. Since its birth in 2010, WebQDA continues to focus on developing features that promote collaborative work, which we all collaboratively research. The fact that this tool works in the cloud enhances collaboration at different stages of a research project. The figure that you're looking at the moment shows the functionality that allows inviting other users. There are 2 user profiles to invite, collaborator and guest. The main difference between the 2 profiles is that one of them only allows interacting in 2 functionalities, insert comments and log entries. In the case of the collaborator, it is possible to encode, but we can activate the option not to allow to decode. For example, we can let them code and then not allow them to change the work already done so that the project manager can analyze the codification made. Regarding data protection, it allows the manager to hide a certain user from the other users. At any time, it is possible to block a user, change the profile, and change the management of the project to another user, provided that he or she is a collaborator. When we work collaboratively, the peer pressure implies greater care in the tasks to be carried out. This other figure shows the encodings of different users. These codifications are carried out in real time. For example, if there are 3 coders in the project and they are analyzing 10 interviews, they can define as coding strategy. 2 of the users code 5 interviews each. Later, the users invert the roles and validate the other users' coding. A third user randomly selects 10% of each interview and validates what the other 2 users carried out. In the example, we call it external validation, when the project involves more than one element. If it is an individual project, the user can resort to external validation using, for instance, one of the validation techniques just mentioned. Comments can be inserted by any user. The functionality allows the project manager or the team to receive expert feedback on the data available in the source system. Comments can be listed by source or by user. The logbook displays the entries of the different users in chronological order. It is also possible to view entries by date, range, or by keyword. In this example, we want to have access only to entries that talk about coding. Considering the advances in research and technology, by discussing the current challenges and needs for promoting data analysis in qualitative research in a broader and more flexible way, the use of software, when carried out rigorously and systematically, enhances the depth of data analysis as well as the quality of the results obtained, up to an optimal, but then again, possible degree of rigor. There are several techniques and there are several challenges to fully overcome the problems placed by analyzing qualitative data. Mechanism for automatic recognition and transcription of data in audio, video, and image formats to text, dynamic importation of bulk data from various sources, creation of aggregation mechanisms in parallel to multimedia data, audio, video, and image, with their respective automatic transcription excerpts, mechanisms for creating mask analysis codes and their automatic coding, incrementation of comparison between processes of the coding of several users within one or several coding systems. Methods for generating qualitative and or quantitative visualization models, for instance, concept maps, matrix graphs, etc. Creation of decision support tools in the process of comparison of classification and coding by various users, promotion of interaction among researchers through the implementation of collaboration, cooperation, coordination, and communication functionalities. These are all things that we are working on at the moment in WebQDA. So we can, so it seems, take several paths as long as there is a destination for our goal and endeavor. In the context of the World Conference on Qualitative Research, we are forming a team to analyze the papers submitted on the use of computer-assisted qualitative data analysis software in its different dimensions. I take this opportunity to invite you to submit an abstract to the World Conference on Qualitative Research. And I thank you for your attention and I'll wait for your questions as well. God bless you.
Thank you so much, Dr. Antonio, for that wonderful presentation. I'm sure that we have gathered many tips and much direction on how we can use this type of computerized analysis in our research. So thank you very much for that. Thank you for providing insights on that. And now we just want to go through a short session on question and answer. I think we have about 15 minutes or a little less than that. And so as you will all see in the chat, you're invited to put your questions in the Q&A chat very quickly so that we can put these questions forward to Dr. Antonio. But as that's being done, I mean, I just have a couple of questions of my own, if you don't mind, Dr. Antonio. You talked about some of the challenges of using computerized analysis. It's something that I'm actually very interested in. And I just wonder where you see it going for the future. I mean, for instance, are there any indications that use of computerized analysis methods will grow in the future? What are your thoughts on that?
Well, as I said a little while ago, of course, that there are things that are going to be a reality in a very short time. One of them is the possibility of doing transcriptions from sound, say, into text very quickly. There's also the possibility that artificial intelligence will hasten the way people interact with the data. You just have to do, for instance, 10% of the coding of your transcripts and then ask the application to do the rest of the coding. Obviously, with artificial intelligence, this is possible, but it doesn't mean that you can rely on the coding. You have to be there as well, because one thing that is never put aside is the fact that you are the researcher, you are responsible for what you're doing, and you should keep a very sharp eye on what the software is doing to your data. But as I see it, there's plenty of room nowadays for improvement in qualitative data analysis software and to make it easier for the researchers to go about their work.
Thank you so much for that. Do you, I mean, I'm just listening to you hearing about the role that, you know, the actual machine will play in the research. It's almost as though researcher and machine kind of merge and work together. How do you think that this might impact on the positioning of the researcher that we've all had so kind of strongly embedded in our minds for very years, especially in qualitative research? How do you think this might affect the positioning of the qualitative researcher?
I think the outcomes of this interaction between researcher and software, and or better still, between researcher and data through software, will become one which is easier for the researcher. But then again, it also asks from the researcher a greater degree of responsibility for the data analyzed. You cannot rely on the machine to do everything for you. You've got to be very much awake as to what the software is doing to the data. Of course, what you set as a first step is that you, as a researcher, code, say, 10 or 20% of the data, and then the software, based on your codes and based on your coding, will do the rest. Of course, one can always ask, well, but the other 80% or 90% of data that wasn't coded by a human being might include aspects that were not in the first set of 10 or 20% of the data that was coded by a human being. So that's why you need to be very suspicious of what the software does afterwards. But then again, the researchers shouldn't be alone in this quest, and having other researchers also get into the bandwagon and do some of the coding will allow for a triangulation between coders, triangulation between modes of coding, and increase the power and rigor of your coding using software, which we hope will be a tool that is more useful than it is nowadays, although it's also now it's a very useful tool because it makes you save time. And one thing that is interesting in WebGDA is that you can start coding before you have all the interviews done, because you can start coding and import new data into the system, and it will go on doing whatever you were doing as a researcher.
Okay, thank you so much for that insight. I have a couple of questions now coming through from the chat, and one of them is, can the coding program that you mentioned, CAQDAS, can it analyze all types of qualitative data? For instance, can it analyze even narratives?
Yes, it can analyze narrative, it can analyze feelings. You can do what is now called sentiment analysis. Yes, the answer is yes, you can analyze narratives, no problem at all. Hyper research software is what we are using currently in that analysis.
Yes,
Do you recommend a better software
question on
for
the screen?
Yeah, for the job, in terms of cost and effort? Well, it's always a matter of doing what is right for the researcher. If you're already into the mechanisms and functionalities of a certain software, the learning curve for another different software, although it might be better at performing, will have to be taken into account. If I'm very good at using hyper research software, I possibly will not commit myself to learning another software to use. But anyway, and that's me being unbiased, because as one of the authors of the WebQDA software, I could say, well, move along and start with WebQDA because it's better at what it can do for you. But that's not the issue. The issue is, do I have enough time to learn how to use WebQDA, because it is going to give me more possibilities.
Thank you so much. I think that we probably do have time for another question. I think it's on the screen already for us. Dr. Antonio. Oh, okay, it's disappeared. Perhaps we don't have time for that question. Oh, okay, there we go. It's back on the screen for us. Dr. Antonio, can you just answer the question? Somebody's asking about WebQDA software. Is what we are using currently in dissertation data analysis, oh, sorry, this is what they're using currently in dissertation data analysis, and they want to ask, do you recommend a better software for the job in terms of cost and in terms of effort?
Well, if you're using WebQDA software for qualitative data analysis, that you're all right, because you have a very powerful tool for your analysis. The issue is, if you're going to deal with a lot of quantitative data, of course, I would recommend another software like SPSS, for instance. But if you're using qualitative, if you're aiming at qualitative data analysis, I would recommend WebQDA, yes. But then again, you can also look for Deduce or MaxQDA. There are several softwares at the moment. I mentioned Deduce because it now also has a possibility of allowing more than one person to be online and doing coding on the fly. The great advantage of WebQDA is that you do not need to pay for an expensive software. You can always decide that you only need 3 months of a license, so that you can analyze your data and filter it into some sort of text that retakes the analysis you've just done. You can forget about that data analysis for a while, and then you can come back again to the same data to work a little more on it, even if a year or 2 or 3 years have gone past. The data will still be there because it's on the cloud. It's in the cloud, and you do not have to install anything. You don't have to be worried about whether your operating system is compatible or not, because WebQDA is in the cloud, and you can go and start coding wherever you are, as long as you have an internet connection. And that's one of the pluses of WebQDA.
Lovely. I think we have time for one more question. This will be our last question. And the question is one I think that's very important to do with collaborative research. So in terms of doing triangulation in analysis, how does that work when you have multiple coders? How does that work?
Oh, that works in a very interesting way. It's as if you were actually using, for instance, Google Docs, where you can actually write collaboratively in a document. You can do that with WebQDA because if you take the decision that your supervisor or your team of researchers should collaborate in the project, you can invite them to the project, ascribe them the profile of collaborator, and you can be at the same time dealing with the same data and coding the same data, regardless of where you are. With no problem at all. You can do it on the fly, and you can even discuss with your colleagues what is being done in terms of getting to some sort of consensus as to what the codes you are using overlap the ones that the others are using or not. You can opt by 2 different paths, so to speak. You can say, let's have a session where we are all together and learn what we need to do in terms of working with this data and start coding and using these coding principles. And everybody does a trial run of the coding process. Or you can just invite, after you've coded 10% of your interviews, for instance, you can invite people to have a look and on the fly again, have an interaction with your colleagues or with your research team members to have the most out of the software.
Thank you so much, Dr. Antonio, sorry, I'm changing your name, Dr. Antonio Moreira. We want to thank you so much for sharing your knowledge, and thank you for taking the time to answer those questions in such detail. I really think people can take your answers and really implement it into their research. So thank you very, very much for sharing with us.
Well, I thank you.
And God bless you. And by way of thanks and appreciation, we have a certificate to present to you at this time, an e-certificate, which is going to be brought up on our screens, I believe. There we go. And this is your e-certificate of appreciation for your contribution, your great contribution to the 6th AQRA International Conference on Qualitative Research. It's been a pleasure and an honor. Dr. Moreira, thank you so much.
Oh, thank you. God bless you.
Thank you.